Hello students, in this the lab practical on the SMAW, that's the shielded metal arc welding or also known as manual metal arc welding process. We'll try to learn the different aspects. So the main objective of this practical is to demonstrate the procedure of arc welding. We impart the information on the various system components and to demonstrate the role of the polarity in SMAW, and also to communicate the fundamentals, working principles, applications, advantages, and the limitations of the shielded metal arc welding.
Shielded metal arc welding is also referred to as stick welding or manual metal arc welding, in short, MMAW, in which an arc is struck between the flux-coated consumable electrode and the base metal to start the welding process. It is the most common type of welding process seen in any job shop industry. Working principle. In this process, the heat required to melt the consumable electrode and form a bond with the base metal is produced by an electric arc struck between the electrode and the workpiece. The shielding for the weld pool is provided by the flux, some of which is deposited on the layer of the weld in the form of slag, which is removed upon cooling. The choice of electrode depends upon the base metal composition. If you are new to ADTW Learn, click on the subscribe button and turn on all notifications so that you never miss an update. Equipment or components of shielded metal arc welding. Power supply. Transformer. Most commonly, welding transformer, a DC rectifier, or a DC generator is used. Electrode holder. Electrode. Ground clamps. Working. First, the power adjustments are made on the transformer. The welding can be carried out by either using direct current electrode positive, DCEP, or direct current electrode negative, DCEN, connection. DCEN. In DCEN, the electrode is connected to the negative terminal and the workpiece is connected to the positive terminal. The electrons thus travel from the negative terminal to the positive terminal. That is, from the electrode to the workpiece. Since there is a sufficient potential difference between the electrode and the workpiece, therefore the electrons from the electrode accelerate and strike the workpiece surface at a very high velocity. Upon striking, the kinetic energy of the electrons is converted into heat or thermal energy, thus an immense amount of heat is generated at the workpiece surface. About 66% of the arc heat is generated on the surface of the workpiece, and the rest of the heat is generated at the electrode surface. This melts the base metal quickly, thus resulting in deeper penetration. However, the deposition rate of the filler metal reduces due to less heat generation at the electrode surface. DCEP. In this polarity configuration, the electrode is connected to the positive terminal and the workpiece is connected to the negative terminal. And hence the flow of electrons is from the workpiece to the electrode. A major amount of arc heat is generated at the surface of the electrode and less heat is generated at the workpiece surface, thus resulting in a higher filler deposition rate and insufficient fusion between the workpiece and filler metal. However, when the electrons flow from the workpiece, the dirt and oxide layer is disrupted, also known as arc leaning action, thus helping in producing a quality weld bead. After setting the necessary current and voltage parameter, an arc is struck by slightly touching the workpiece with the electrode and carrying forward or backward. Once the arc is struck, the heat generated melts the electrode and base metal, and the filler metal gets deposited on the base metal. The electrode should be held at a lower angle to the workpiece to initiate an arc and to carry on the welding process, but if the electrode is held perpendicular to the workpiece, then it is likely that the tip of the electrode may stick to the workpiece and fuse, causing it to heat up rapidly. The flux then converted into a shielding gas surrounding the weld pool, protecting it from oxygen and other atmospheric contaminations. Some of the flux gets settled on the weld puddle in the form of the slag. Once the welding is completed and the weld bead is cooled down, the slag is chipped off using the chipping hammer and cleaned using a wire brush. Shielded metal arc welding can be used to weld in all positions. That is, flat, horizontal, vertical, and overhead. Advantages. The initial cost is low. The welding equipment is simple and portable. Flexibility of the process in using a wide variety of electrodes. The electrode is flux-coated, which provides shielding, hence no need for heavy gas cylinders of shielding gases. An efficient and low-cost way of joining metals. And good for welding in tight spaces. Disadvantages. A highly skilled person is required to produce a good quality weld. Defects are hard to detect in the weld. The process is manual and hence high labor cost. Fumes and gases produced by the flux are hazardous. Application. This process finds its application in structural welding, job shop, shipbuilding, field repair, marine, aerospace, and nuclear. Hope you have understood.
So some of the questions for self-assessment includes like what is the meaning of the ground connection in SMAW, and what is its role, especially with regard to the arc flow, and what should be considered while selecting the polarity for SMAW. So what are the different points that we should keep in mind? Then what are the typical applications of SMAW, and how does the SMAW provide the protection to the weld pool from the atmospheric gases? If there is no proper protection, then various types of the weld defects are